Hi everyone and welcome to the video. I was actually able to get my hands on two RTX 3090 Founders Edition graphics cards. I will use the cards on the one hand for mining, and on the other hand I will do some AI calculations with it. So I need compute power, and the more is even better. The card is quite impressive. It's huge. In comparison to an GTX 1080, it's way bigger. It really takes up some space in your case, as you can see here. It is a 3-slot card. It's rated up to 350 to 400 watts power draw, and this is why the cooler has to be so big. For my project, the idea is to use an existing Corsair case. It's the 400C mid-tower case. And on the one hand, it should be quite limited regarding the space for the graphics cards. But on the other hand, my idea was to keep it compact as possible. And I was quite aware that this could become a problem. So I realized it's necessary to make some tests up front to understand how the VRAM temperatures actually perform when there's a single slot card in the case, and how hot the VRAM actually gets, and if it is necessary to watercool the card. So I started a test here running Firmark and analyzing the temperature development over time. First of all, I started with a limited power draw of 170 watt, around that. And you can actually notice that already the VRAM gets way hotter than the GPU die. After that, I increased the power step by step and actually watched the temperature trend of the GPU temperature and the memory temperature especially. And always keep in mind, this is a card running in an open case with the standard cooler, standard configuration from NVIDIA. So now we let it just run for a bit and see how the temperatures increase. And here we are now. So the card is pulling 350 watts power, and the memory temperature is actually above 95 degrees Celsius. So it's around 15 degrees Celsius away from actually thermal throttling, but it's still way too high for my ambition. Especially if you want to place two graphic cards in a dense case, this is never going to work out. The cards will absolutely overheat, and yes, they do. So here we are now looking at the picture with the cards in the case. So actually they fit in. I mean, they take up all the PCIe slots, and there are 6 of them. It looks really massive and really cool. It's actually a very good look, but the problem is, as you can see here, like there's 0 space for airflow. So this is the biggest problem. I mean, the cards are actually from the design. Looking at the design, they are actually designed that way that the PCB is only that long, and the rest of the card is only the cooler and the fan. And the cards are actually able to pull through air through the metal and the fan in this way. So I guess the design of NVIDIA, or the design thought of NVIDIA was, okay, we actually need to be able to pull some air through it to increase the cooling capacity. But overall, the cooling capacity of the cards is not enough. So if you think about this block here, this area is actually producing, if you run it at full capacity, 700 watts of heat that need to be turned into air and removed from the card. So this is regarding the energy density is a big problem. And even though the cards are super heavy, they are not able to get rid of the heat and especially cool the VRAM enough in this setup. So the plan will be to actually turn this case into a fully water-cooled rig and keep it actually with the mid-sized tower very small. And yeah, the results of this will be shown in future videos. Thank you for watching and subscribe if you want more content.